Yeah, fine. See, yesterday we discussed about up to the horizontal surface, right?
Yes, sir.
Now, you see, I think we discussed on the two bodies we discussed. Today, we'll discuss about on the same horizontal surface, we'll discuss the three bodies. Okay. Suppose let us consider on the horizontal surface like this. Okay. We are having the objects like this one, it is M1. Okay. Is connected by a string. This is M2 and connected by another the same string. It is M3. Such that here you can see this part and this part. It is made up of with one string only. Okay. With one string only. Whenever a force is acted, such that, okay, first I will draw the free body diagram. M1G, M2G, and then M3G. Okay, normal forces, that is N3 and N2 and N1. Okay, so that we'll have the acceleration along the direction of the force applied. Okay, here we are having the force applied like this. So we know that it is F is the total external force acted on the system. That is here the system it is, we are having the three objects M1, M2, M3. So I can write it as F1 plus F2 plus F3. That is nothing but M1A plus M2A,
M2A plus M3A.
M2A plus M3A, right? So from this I can write it as acceleration equal to F by F divided by,
M1 plus M2 plus M3.
okay, fine. Okay, acceleration we don't have any problem. Now see, whenever I'm pulling the with a force, see here, then what will happens? First M3 will move and then M2 and M1 will move. Okay, so we need to apply a force, okay, such that we need to keep M3 in equilibrium. So there will be an opposite force will act. Okay, I am calling this one as T2. Okay, now whenever we are pulling M2 and M3, okay, as M2 and M3 changes, M1 will be changes. So in order to keep M2 and M3 in equilibrium, we are applying a force. This one as T1. This one as T1. Okay. Okay. I want to find T1 and T2. I want to find T1 and T2. Okay. You can see here T2 I can write as just like in the previous example, yesterday's class, you can see F minus T2, I can write it as M3A. Right? Dhanavirika. Dhanavirika.
Yes, sir.
Yati. Antena.
Yes, sir.
Okay.
Yes, sir.
Mechanics, it is the, okay, beauty in the physics, where if you see, if you parents or elders, anyone will says that about physics, it is about the real things or real events. One of the, it is mechanics, where you can observe every phenomena in the real life. Okay, suppose if I am pulling it, So due to the resultant of this F and tension T2, I am having the motion in the object M3, that one. So here I know that F means, here I know that F is equal to M1A plus M2A plus M3A minus T2 is equal to M3A. Okay, so I will get it as T2 is equal to M1 plus M2 into A. So I can write it as, since I know the acceleration, I will write it as M1 plus M2 into F by M1 plus M2 plus M3. Right? Now see here, it is, I am applying force F towards the right. T1 and T2 are acting towards the left. Towards the left. That means how much force is acting towards right, that much force to act, okay, to act in the opposite direction. Then only the object will be in equilibrium. Entire the system will be in equilibrium. Right? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
I am applying a force F towards the right, and T1 and T2 are acting towards left. Suppose if F is equal to T1 plus T2, F is equal to T1 plus T2, then entire the system, that is three bodies and the strings, will be in equilibrium.
Yes, sir.
Ante kada?
Yes, sir.
Okay. Okay, fine. Suppose if, let us consider, if F is greater than T1 plus T2, then what will happen to all the objects?
Entire body will move with a force, sir.
Okay, so all the bodies, we are applying force towards right. So M1, M2, M3 will move towards the right. Okay, so this is the case of non-equilibrium, and F1 is less than T1 plus T2. When applied force is less than T1 plus T2, what will happen? What will happen? Can anyone guess?
It will not
Body
move.
will move.
Body doesn't move.
Exactly, body does not move. Okay, we don't want these two cases. So always we want, okay, why we, in the yesterday's class, why we want the this one free body diagram means, as I told you, that is how much force is applied on an object to keep the object in equilibrium. That means I need to apply a force T1 plus T2. Already F means this one, this is the value F. See, T1, T2 I got, that is M1 plus M2. Then what will be the value of T3? T2 I got it as M1 plus M2 into A. M1 plus M2 into A. Right? Okay. And F is equal to M1 plus M2 plus M3 into A. Okay. Then what will be the value of T1?
M3 into
M3.
A by
M3A. So acceleration we will substitute the value. That is M3F by M1 plus M2
M2
plus.
plus M3.
Okay. Say for example. Huh? Ena? Hello? 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 Okay, fine. Now, okay, let us consider an example. Let us consider an example. Suppose here I'm having the 4 kg, and here I'm having 2 kg, and here I'm having 1 kg. Okay, I am applying by a force 21 Newton. Then I want to find what will be acceleration T1 and T2. T1 and T2. Okay, acceleration formula
F
by M1
by
plus M2
M1
plus
M2
M3.
plus M3.
M1 plus M2 plus M3 అంటే 7 కదా. అంటే 21/7 you will get as 3
Three.
meter per.
Meter per second.
3 meter per second.
ఇక్కడ మనకేమనుకున్నాం T2 అనుకున్నామా?
T2.
అంటే ఇక్కడ మనకేంటి 21 ఉందా? అంటే 21 minus T2 is equal to A అని రాయచ్చా?
Yes, sir.
Sir.
T2 ఎంత 18 న్యూటన్ అయినా
Yes, sir.
ఇక్కడ ఎంత ఉండాలి? 3 న్యూటన్ ఉండాలా? అంటే T1 ఏమనుకున్నాము? M3A అనుకున్నామా? ఇది M3A కదా?
Yes, sir.
M1 సార్ M1 అవుతుంది కదా సార్
ఏమన్నా
Hmm?
M1 అవుతుంది కదా సార్
See,
3 1 3 no.
F minus T
Same.
equals to
F minus of T1 plus T2. F minus of T1 plus T2. Okay, will causes the motion in M2 and M3. Hello. Here I can write it as F minus of T1 plus T2 is equal to M2 plus M3 into A. Antena? Resultant of force and T1 and T2. This force and T1 and T2 will causes the motion in M2 and M3. Antena? అయితే ఇక్కడ చూడండి, ఇక్కడ వాట్ ఇట్ ఈస్ ఎఫ్ అంటే నాకు తెలుసు M1A ప్లస్ M2A ప్లస్ M3A మైనస్ T1 మైనస్ M1A మైనస్ M3A మైనస్ M3A.
సార్
అంతేనా?
M2A
M2A, sir.
1 minute. T2 నా M2A. ఓకే, ఇక్కడ ఏమైంది? M1A క్యాన్సిల్, M2A క్యాన్సిల్. ఓకే, సో హియర్ ఇట్ ఈస్ దట్ ఓకే వాట్ ఎవర్ ద ఫోర్స్ ఈజ్ యాక్టెడ్ ఓకే హియర్ F is equal to T1 plus T2. So here what will happens? Net acceleration will be 0. అంటే T1 is equal to M3A. There will be no motion in this one. Okay, that one, that is on the horizontal surface. Suppose let us consider I am having a horizontal surface and here I am having the objects. You can see in your real life, okay, what we used to do it is we'll place the books on the floor. Suppose this is M1, this is M2 and this is M3. Okay, if I am applying a force F, here I am applying a force F. Now for which object weight will be more and for which object normal force will be more? Can anyone tell?
weight will be more for M1.
Weight will be more for M1. Very good.
For M3
Okay.
normal.
Normal will be more for
M3.
M3, sir.
That means if we draw the free body diagram, okay, see for M1, the normal force, it is N1. And normal force of M2 will act on this one. So the total normal force which will act on the M3, that is here will be along with N3 will have N1 plus N2 plus N3. Any third object normal force and as well as N1 and N2, right? So the normal force for third object will be more than the first object. Similarly, weight of M3 will act on the second object and weight of the second object will act on M1. So along with weight of the first object, we'll have the remaining two objects. That is, we'll have M1 plus M2 plus M3 into G. Right? Is it right? Okay, fine.
Yes, sir.
Suppose let us consider if I'm applying a downward force. Okay, with an acceleration A. with an acceleration a. Now, I want to write the equations. Whenever I am applying a pushing force, then what will happen? The object will goes downwards. See, for example, whenever you are packing the luggage, Kartikeya,
సార్ స్నేహిత
చెప్పమ్మా.
సార్ ఫస్ట్ ఆబ్జెక్ట్ మీద M2 ఇంకా M3 రెండు యాక్ట్ అవుతాయి కదా వెయిట్.
ఫస్ట్ ఆబ్జెక్ట్ మీద అవును అవుతుంది.
మీరు ఓన్లీ M2G అని రాశారు.
లేదమ్మా, ఇగో ఇక్కడ నేనేం రాశాను, ఈ M3G ఈజ్ యాక్టింగ్ ఆన్ M2 అండ్ దిస్ వన్ ఈజ్ యాక్టింగ్ ఆన్ సెకండ్ ఆబ్జెక్ట్ వెయిట్ ఈజ్ యాక్టింగ్ ఆన్ M1. సో along with the weight of M1G, we'll have the total weight M1 plus M2 plus M3 into G. ఈ రెండు ఆబ్జెక్ట్స్ యొక్క వెయిట్ ఉంటాయి కదా.
సార్ మీరు M2G అని రాశారు కదా, అక్కడ M2 ప్లస్ M3 ఇంటూ G రావాలి కదా.
నేను ఫస్ట్ ఇక్కడ ఇండివిజువల్గా రాశాను. ఇప్పుడు థర్డ్ ఆబ్జెక్ట్ వెయిట్ M2 మీద ఉంది అంటే M2 యొక్క వెయిట్ ఇక్కడ యాక్ట్ అయింది అంటే ఇక్కడ టోటల్గా ఎంత ఉంది, సరే ఓకేనా, M2 ప్లస్ M3 ఇంటూ G. ఓకే
ఓకే
here it is M1 plus M2 plus M3. Okay, M1 is having along the weight of the first object, we are having the weight of the second and third. That's why I wrote here. Here I am writing individual weights. Okay, now suppose let us consider the situation whenever you are going to outstation while packing the luggage. Okay, after packing also still some items are there, then we will apply a downward force. Okay, anytime observed it.
Yes, sir.
Yes,
Okay,
sir.
that is the case, that is my case. Okay, that is the case. Okay, whenever we apply a downward force, then what will happens, it is here, it is the force. Due to this force, we will have the motion of the object or item, whatever it is. Okay, so since it is moving downwards, the downward force is more than the normal force. So I can write it as M3G minus of normal force N1 plus N2 plus M3 is equal to M3A, right?
Yes, sir.
Similarly for M2, that means in these kind of problems, we need to analyze and we need to think. If the object is moving downwards, what I know it is downward force is more than the upward force. So downward force minus upward force equal to motion in the block. Similarly, M2 also. Here the object is moving downwards. Okay, so downward force is more. That is on M2, the total weight will be M2 plus M3 into G. Right? Minus normal force, that is N1 plus N2 is equal to, okay, that is M2 plus M3 into A. Along with M2, this M3 will also move. Right?
Yes, sir.
Kathy,
Yes, sir.
అర్థమవుతుందా?
Yes, sir.
ఎందుకంటే ఈ మెకానిక్స్ అంతా కూడా ఏంటంటే కొంచెము ఆలోచించాలి, సిట్యుయేషన్ అర్థం చేసుకోవాలి మనకి, అందుకని. ఓకే, అయితే అలాగే M1కి వాట్ ఐ కెన్ రైట్ ఇట్ ఈస్ M1 ప్లస్ M2 ప్లస్ M3 ఇంటూ G minus N1 is equal to M1 plus M2 plus M3 into A. By using these three equations, I can find acceleration and then normal force N1, N2 and N3. Okay, normal force N1, N2 and N3. Okay, these are the possible cases in the horizontal surface. If you observe this one, now today, okay, in the evening after your classes, all your classes, okay, all of you, what you should do it is draw the free body diagram, okay, in your notebook or in your rough notebook or practice notebook, okay, this diagram and this one, 3 bodies and 2 bodies. All of you must and should draw and send it to my WhatsApp and send it to the in the group. Okay. Next one, second one, it is the case that is, if you observe carefully, this type of case will get in the friction. We'll call it block on block. Anytime anyone saw?
Yes, sir.
Sir.
Okay.
Yes, sir.
That is, there we'll discuss in detail with friction. Here it is, we are discussing the basic point. What are the forces that acts on the objects which are placed one over another? One over another. Okay, fine. Next one, it is vertical wall. Vertical wall. Okay. Suppose let us consider I am having a vertical wall like this. Okay, which is a smooth surface, frictionless. Here I'm having an object is placed. Okay, generally in our home, what we will do it is, okay, generally in some of your home, you will have the personal room. You will have the personal room. In that personal room, some people, what they will keep it is, they will keep the posters like Abdul Kalam or Sachin Tendulkar. Like this, they will keep the posters. Okay, anyone is having? Anyone is having? No one? Okay, no one? Okay, fine. Suppose, say, or else you can see in the colleges, what they will do is they will post the, sorry, they will pin the notices to the wall. If they are not having the notice board, okay, they will paste the notice to the wall. Anytime observe this one.
Yes, sir.
Yes,
Why?
sir.
While doing this one, what I will do, I will apply a force towards the wall. Okay, and weight will act, okay, from the center of object vertically downwards. I am having the weight. Okay, okay. Here the object is in contact with the surface. This one. So in which direction we are having the normal force?
Opposite to the force.
In this direction. In this direction, sorry, we are having the normal force. In this direction, we are having the normal force. Very good. Now, see here it is. Does this object will have tension?
Yes,
Any
sir.
tension?
Sir.
Hmm?
Yes, sir.
Yes,
Uh,
sir.
Yes, sir.
which direction? Does this object will have tension?
Upward direction.
Off.
See what I told for the tension. Tension
Contact force.
will act. Tension will act when it is suspended. When it is suspended or whenever it is in contact with the another bodies or another objects. Okay, another objects. See, on the horizontal surface, if I'm having an single object, okay, does this object will have any tension?
No, sir.
No, sir.
No, sir.
Why, sir? Why, sir? Here also contact is there, na, sir?
It is not
Chandrakant?
suspended.
Okay, here it is that whatever the force is applied will have the motion only. Will have the motion. If it is in contact with another object, suppose M2, then we'll have, here it is the contact force. Due to this, we are having a tension. Okay, here we'll have a tension, will act. Okay, like this. but not the object is pasted or connected to an vertical wall, to a vertical wall. Okay, so all of you please remember that under which cases tension will act. Under which cases tension will act, that is the most important. Suppose this is the wall, this is the wall, and here I'm having an object of mass m1, and here I'm having an object of mass m2. M1 is not equal to m2, such that I am applying a force towards the wall, towards the wall. Okay, okay, correspondingly we'll have the weights from the center of object, right? Okay, what will be the normal force? See, this m1 is in contact with the surface, and here we are having an m2 is in contact with the surface of m1. In which direction will have the normal force? The normal force of m1 will act on m2. Can I say? Chapacha.
Yes, sir.
Yes, sir.
The normal force of m2, okay, it is n2, such that n1 is also acting on the m2. So, though the total normal force it is n1 plus n2. Antena? Okay, fine. Normal force we got it. Okay, and then force we got it. So that means whenever a force is applied, now I want to find in which direction we'll have the acceleration. In which direction we'll have the acceleration? Towards the wall or away from the wall or perpendicular to the wall? Towards the wall or okay, away from the wall or perpendicular direction, in this direction. In which direction we'll have? Anyone? Chandrakant?
Sir, I think perpendicular.
Uh-huh.
Downwards, sir.
Downwards. Next. Vaishnavi?
Sir, downwards. నేనే చెప్పాను సార్.
Akash? Akash?
Sir, in
Akash.
direction of force.
In direction of force. Sri Harshita? Ma Harshita? ఏ డైరెక్షన్లో ఉంటుంది యాక్సలరేషన్? ఇందాక ఎవరో డైరెక్షన్ ఆఫ్ ఫోర్స్ అన్నారు, ఎవరమ్మా అది?
నేను వైష్ణవి సార్.
నువ్వెందుకు ఆన్సర్ మార్చావు? ఇందాక డౌన్వర్డ్స్ అన్నావు, ఇప్పుడు డైరెక్షన్ ఆఫ్ ఫోర్స్
సార్
అన్నావు.
మాది ఫోర్స్ డైరెక్షన్ లోనే యాక్సలరేషన్ ఉంటుందని చెప్పారు కదా.
వెరీ గుడ్. ఎప్పుడైనా గుర్తుపెట్టుకోండి, ఎనీ టైమ్ ప్లీజ్ రిమెంబర్ దట్ ఆల్వేస్ ద acceleration of the object will depends upon the direction in which force is applied. We'll have the acceleration either away from the wall or towards the wall. Okay, suppose if force is greater than the normal force, if F is greater than the normal force, then acceleration will be towards the wall. Suppose if F is less than n1 plus n2, then it is away from the wall. Suppose I'm having a notice or I'm having a paper. If I'm applying more force, then the paper will stick into the wall, or stick on the wall. అక్కడ వాల్కి పేపర్ అతుకుపోతుంది, అంతేనా? అంతేనా? అదే నేను అప్లై చేసే ఫోర్స్ తక్కువైంది అనుకోండి, ఏమవుతుంది? ఆ పేపర్ అనేది వాల్కి అతుక్కుని పోదు, కింద పడిపోవటమో లేకపోతే ఇది జారిపోవటమో అవుతుంది, అవునా? అవునా? ఓకే, ఐ థింక్ ఆల్మోస్ట్ అందరూ ఒక 10 days బ్యాక్ ఏమో, ఐ థింక్ వినాయక చవితి అయినప్పుడు చూడండి, వినాయక చవితి అయినప్పుడు మీరేం చేశారు? మీ ఫాదర్ కానీ మదర్ కానీ ఇంట్లో పాల వెళ్ళి కట్టుంటారు. కట్టారా? కట్టారా? పాల వెళ్ళి ఇట్లా స్క్వేర్ షేప్లో ఉంటుంది.
ఎస్ సార్.
ఆ పాల వెళ్ళికి ఎట్లా కట్టారో చూడండి. మెయిన్గా ఫస్ట్ ఏం చేస్తామంటే కార్నర్స్లో ఒక ఫిక్స్డ్ ఎండ్ నుంచి దారం నుంచి తీసుకుని అక్కడే టై చేస్తాం. ఆపోజిట్ కార్నర్స్ అది అప్పుడు ఇంకా బ్యాలెన్స్ అవ్వదు. ఇంకొక కార్నర్ తీసుకున్నాం. ఓకే, ఇంకొక కార్నర్ తీసుకుని దాన్ని టై చేసినప్పుడు అప్పుడు ఏమవుతుంది, ఆ పాల వెళ్ళి బ్యాలెన్స్ అవుతుంది. అయిందా? అవునా? బాగా అబ్జర్వ్ చేయండి. ఎందుకంటే many people says that it is Albert Einstein discovered the photoelectric effect or relativity, but I likes one of his statement. It is observation is more important than knowledge. Observation is most important for any science student. Okay, we need to observe the phenomena very strongly and firmly. Okay, fine. So here what I can write it is, whenever the acceleration is towards the wall, I can write F minus of n1 plus n2 is equal to m1 plus m2 into a. Can I write?
Yes, sir.
Yes, sir.
Okay. Okay, for m1 I can write. Okay, for individually I can write for n1 and n2. Individually I can write for n1 and n2. Okay, like this here also we are having that. Okay, we are having three objects. Okay, okay, just understand the logic here. Whatever the force is applied, we are having a normal force. We are having a normal force. Okay, and my request or my advice it is, again all of you draw free body diagram, this free body diagrams whatever we are discussing in your notebook, and next third one it is that it is Atwood machine or pulleys. Atwood machine. Atwood, it is the name of the scientist. Okay, this Atwood machine, okay, it consists of a circular wheel. Having a radius as r. R is the radius. From the center of the wheel, okay, it is fixed to a fixed rod. Whenever it is fixed, does the wheel rotate?
No.
No, sir.
Right?
No.
That means here we are considering that there is no motion in the wheel. Or there is no motion in the pulley. Okay, and here in the JEE mains level or in the NEET level, we are having that the mass of the pulley is having massless, very light. In the JEE advanced, we are having the mass of the pulley. Okay, whatever the basics we are studying, okay, in addition to that we are having mass of pulley, just we will have some addition value. That's it. Okay, so firstly what I will do it is I will firstly consider the mass of the pulley as massless and there is no motion in the pulley. Okay, there is no motion in the pulley, and after that I will consider the mass. Okay, let us consider here I am having an mass m1 and this one as mass m2. Here I am considering the case that m1 is greater than m2. Suppose let us consider, okay, I am having a rod. In this rod here I am having an suppose 25 kg, At this end, I am having the 2 kg. In which direction this 25 kg will move?
Downward direction.
Downward direction.
Okay, vertically downwards. Downwards, if we say that downwards, it can be in any direction, like this or like this or like this. All this comes under downwards one. So preferably, I'll say vertically downwards. Vertically downwards. Okay, and this one, this 2 kg will move vertical upwards.
Yes, sir.
So
Yes, sir.
like that here also, okay, what I will do it is M1 is greater than M2. So M1 will accelerate down and M2 will accelerate up. Okay. Why with same acceleration means you can see this I will call an A and here it is B. And approximately this is the point C, that is this one. And here it is D. So I am considering the length of the string as AB plus BC plus CD. That is the total length of the string. And we are considering that the length of the string is inextensible, okay, massless and weightless, right? Antena. So BC, you can see here BC, it is a semicircle. I can write it as pi r, where r is the radius of the coil, which is a constant. Which is a constant. That means if I differentiate it, okay, that is dl by dt. Since L is a constant, that is 0. So velocity of AB plus velocity of CD will be 0. Right? Antena. Whenever the string CD is moving upwards, that is velocity will be decreases or the displacement will be decreases. Right? Antena.
Yes, sir.
Here, whenever it is moving downwards, the displacement increases. So, with as the displacement increases, we can say that velocity will also be increases. So, what I will do it is for M2, that is CD, it is decreasing. So, instead of plus, I will keep it as minus. Okay, fine, understood. The same principle we will use in the constraint equations and pseudo forces. Whenever the mass is moving towards the center of the pulley, what will happen? The displacement decreases. Due to that, velocity will be decreases. Whenever the velocity decreases, we'll indicate with minus sign. Here AB, the displacement is increasing. So as displacement increases, velocity will be increases. So VAB. If I differentiate again with respect to time, I will get acceleration of AB is equal to acceleration of CD. Right?
Yes, sir.
That is equal to A. That is equal to, I am considering acceleration of AB and acceleration of CD. It is A. That is along CD with how much accelerating it is moving upward direction. With the same acceleration, it is moving downwards. It is moving downwards. Now, observe the thing that, okay, carefully observe. What will be the direction of motion means here M2 is moving around the pulley and it is moving towards M1. Right? Antenna?
Yes, sir.
Yes,
In this
sir.
direction. So, in every diagram, you must understand direction of motion. How the pulley is rotating or how the objects are moving around the pulley. Okay, if you can understand this one, you can able to write the equations. Firstly, I will draw the free body diagram. Okay, here we'll have the weight will act for M2, the weight will act, that is M2G. Okay, that is M2G. Okay, now okay, fine. And Here there is a motion, that is upward direction, right? Now this object M2 is suspended from the pulley such that pulley is connected to a fixed rod, right? So here we are having a tension will act towards the point of suspension of the pulley. Antena? Is it right?
Yes, sir.
Yes, sir.
Okay. M2 is not in contact with any surface. So here we don't have any normal force. We don't have any normal force. So here it is tension T. Okay. This is entire one string only and acceleration is same. So similarly, I can also write it as tensions will also be the same. Tension for one string, it will be equal.
Yes, sir.
Yes, sir.
So here also tension T will act towards the point of suspension of pulley. Vertically downwards from the center of mass of object will have the weight M1G. Right? Okay. Now I can write the equations in the two manners. First, I will tell the first manner. You can see whenever it is accelerating upwards, that is upward force is more than the downward force. Right, sir? Upward force is more than the downward. That means I can write it as T minus M2G is equal to M2A. Avuna?
Yes, sir.
Right? Call it as equation 1. Here for M1, it is accelerating down. It is accelerating down. So downward force is more than the upward force. So for M1, I can write it as
M1G minus T
very good, Nana. M1G
equals
minus
to
T.
M1A.
M1A.
Okay, this is one manner. Okay, next second method it is, carefully see, M2 for M2 I'm writing. Here it is accelerating up. We are having gravity in the downward direction, vertically downward direction. So I can say the relative acceleration. If two particles are having the velocities v1 and v2, what will be the relative velocity? What will be the relative velocity?
V2 minus
Minus V1.
V2 minus v1 or v1 minus v2, anything. Okay, or v2 minus v1. Okay, fine. If these two particles are moving in opposite direction, then what will be the relative velocity? Moving in the opposite direction, what will be the relative velocity?
V1 plus V2.
V1 plus V2. So I can write net acceleration as A plus G. Right, sir? Here it is moving in the opposite direction only, na? Right?
Yes, sir.
Okay. Now multiply with mass M2A net is equal to M2A plus M2G. Antena? This is the motion or applied force, and this is the weight. Resultant of weight and motion of the object, we are having the tension only. So T is equal to M2A plus M2G. If we rearrange the equation, T minus M2G equal to M2A. Antena? Antena?
Yes,
Yes,
sir.
sir.
మనకు అదే కదా ఈక్వేషన్ వచ్చింది చూడండి.
Yes,
Yes,
sir.
sir.
అలాగే ఇప్పుడు M1కి రాస్తాను చూడండి. ఇదేంటి? It is accelerating down. Accelerating down means net acceleration I can write as G minus A, just like here V1 minus V2. G minus A. Okay, fine. Now here why I wrote G minus A? Why not I should write A minus G? Can anyone tell?
That means Towards down.
Acceleration is down.
So what? Next, anyone?
Gravity is moved.
Gravity is
Moved
very good.
complete.
Very good. Among all the forces, gravitational force is most strongest force. Okay. With respect to the acceleration, that is MA, we'll call mechanical force. First, it is gravitational force, next, electromagnetic force, and then atomic and nuclear forces, and then finally, mechanical force. Okay. See, in the very first chapter in your NCERT textbook or in your board textbook, we will have a chapter called Physical World. Physical World. That is, that chapter will explains about what are the phenomena, okay, or what are the quantities which we are using in our daily life. Okay, I think in the page number 3 or page number 4 at the end, they gave the types of forces: gravitational force, electromagnetic force, that is electric force and magnetic force, and then atomic and nuclear forces. Okay, and then finally it is this one, mechanical force. Atomic force will be in the order of, okay, 10 power minus 12 to 10 power minus 19. Okay, nuclear it is very less. Okay, fine. So here I got the equations as T minus M2G is equal to M2A. And another equation I got it as M1G minus T. M1G minus T is equal to M1A, called as equation 1, this one as equation 2. If we add two equations, 1 plus 2, I will get as M1G minus M2G is equal to M1 plus M2A. Antena, is it right? So acceleration is equal to M1 minus M2 into G by M1 plus M2. Antena, Divya, Tarun, Aditya,
Yes, sir.
Antena. That is the acceleration of the pulley connected by two bodies. Here, if you observe carefully, I considered M1 is greater than M2. So M1 minus M2 into G by M1 plus M2. We got it. Substitute the value of acceleration in any of the equation. I'll substitute in the first equation. That is T minus M2G is equal to M2A. That is T is equal to M2G plus M2 into M1 minus M2 into G by M1 plus M2. That is T is equal to M2G take common 1 plus M1 minus M2 divided by M1 plus M2. That is nothing but M2G into 2M1 by M1 plus M2. So tension T is equal to 2M1 M2G divided by M1 plus M2. That means this much of force should act. This much of force should act to bring M1 and M2 into equilibrium. This much of force must act to bring M1 and M2 in equilibrium. Okay, na? Okay, fine. That is what. Okay. Tomorrow we'll discuss, okay, some more models on the pulleys. Some more models on the pulleys. And remember that most of the students will have a doubt that if we are having the more than two pulleys or more than the three pulleys or inclined plane with pulley and spring, okay, don't get fear and don't get scared with those type of systems. We are having the shortcuts also. Okay, even I know that shortcuts. Okay, so don't get scared or don't get beware. Slowly we are learning. Okay, especially track one, slowly. Why I'm going slow? It is each and every basic point you must understood, and afterwards you must apply it. You must apply it. If you are successful in mechanics track one, mechanics, Okay, that means damn sure it is 98 to 99.999%. You will get JEE Mains. You will get a good rank. Okay, that's why I'm going the slow, because of the you need to understand everything. Afterwards, we need to draw the free body diagram. Okay, by evening, I will send some systems. Please try to draw the free body diagrams. Free body diagram. Okay, that's all for today. Tomorrow we'll meet.
Thank you, sir.
Okay.
Thank you, sir.
Thank
Okay.
you, sir.
Again,
Thank you, sir.
again, we'll meet at 11:30. Track 2, thermodynamics, sir.
Okay, sir.
Okay, sir.
Yes, sir.
Thank you, sir.
Okay.